You cannot do that with MES. That's why there are so many more people who can do SCADA than there are MES, because MES is a digital MES is a digital representation of your unique business. That doesn't mean that there aren't some key functions of manufacturing execution that everybody uses, but there are hundreds and hundreds and hundreds of possibilities of features in an MES system. And MES is not MES is not MES. You go to 3 different manufacturers who all have digital manufacturing execution system, and you're going to see 3 things that kind of resemble one another that are completely different. Okay, and what we're going to talk about today is we're going to talk about what is MES. We're going to do an introduction into manufacturing execution. We're going to talk about what is MES, and then we're going to talk about the core 4. So what are the core 4 features that basically everybody builds in every single manufacturing execution system? I don't think I've ever seen an MES system that doesn't contain these 4 features. Whether someone has built it purely in .NET, or wrote it in C# with a Postgres backend, and they wrote it completely from scratch, or they bought it off the shelf. I haven't seen any MES that doesn't have these core 4 features. So if you have questions, we have Zach monitoring. If you have questions, just ask him in the chat. Or not Zach, we have Vaughn monitoring. Ask him in the chat. Vaughn, any really important question that we need to answer, Vaughn will flag it and he'll put it up on the screen for us to answer. And Zach will let me know if I'm not looking at the screen at any given time. With that, let me bring in Zach Scriven. You guys all know him. But Zach, how's it going, dude?
It's going well. I'm glad to be here. I'm excited to show off that demo that I made and to get people started with building out their own MES capabilities. If you're not tracking your downtime, if you're not tracking your machine states today, you need to start doing it like right now. There's probably a lot of people out there who have an IIoT platform, or they have free tools that they can use to build out this capability, and they're not doing it. So I'm excited to learn, what you have to share, and then I'm also excited to share my demo and leading into the 8-week MES Bootcamp. So yeah, let's get started.
With that, let's get in here. So
we all right, so 90 minutes, and we have 60 minutes of presentation. We're going to stay late for questions.
Correct. Yep. All right. So here we go. So let's start with what is the bootcamp. So this webinar, whether you're taking the bootcamp, whether you're doing the bootcamp accelerator or not, this webinar applies to people who are doing the accelerator or are not doing the accelerator. This webinar applies to basically everybody. But understand the reason we're doing it is because a couple of years ago, we did an MES bootcamp. It took us about 6 months. We did 8 sessions. There were actually 7 development sessions, and there was 1 Q&A. We are getting ready, starting next month, to do a accelerator of that bootcamp, similar to the accelerator that Zach led for the mastermind program. So in the bootcamp that we did a couple of years ago, we were teaching you how to build the core capabilities of an MES system using an open platform, using unified namespace, and using an MQTT broker. We also used a MySQL backend, and we used Python. We used external Python for scripting, and we also used the Ignition Python API for scripting. It was 8 sessions, 7 of which ran about 4 hours. So session 1 was intro to MES. Session 2 was setting up Ignition, the IoT platform we use for that bootcamp. Session 3 was Python. We were writing all the core scripts to build our MES system. Session 4 was user defined data type. So we built our dispatch data type. We built our OEE data type. We built a whole series of UDTs for the MES system. Session 5, we built Windows. We showed manipulating images, and we did our production model testing. Session 6, we did code updates. We did backup and restore. Then we did a 1-hour bootcamp Q&A before we came back for session 7, and we did our OEE package walkthrough and wrap up. The bootcamp is students who are doing the accelerator are going to go through the bootcamp session by session, but led by a cohort educator, which is Zach. So the first session is January 7th. Okay. The second session is January 14th. So I got these off. The third session is January 21st. The fourth session is January 28th. The fifth session is February 4th. The sixth session is February 11th. And then you're going to do Q&A. We're going to skip the week for the Prove It conference. There won't be, we're all going to be at the Prove It conference in February. Then you'll come back, do session 7 and your Q&A across that spread. All right. All right. So that is why we're doing this webinar. All right. The agenda for the webinar.
One quick question. Someone asked, do I need Ignition to get value out of this this boot camp?
Do you need Ignition? You will need to use Ignition as an IIoT platform. Well, if you there's 2 sessions in there where Ignition is obviously really, really important. So the user-defined data types, we're using Ignition's UDT engine. But if you look at the Python, all of that was like external. We actually did external Python coding like in PyCharm. With the idea was for the MES engine to be decoupled from the IoT platform. But I would say yes. If you're going to do the accelerator, you should plan to use Ignition as the IoT platform. You can download it for free. And what we had was we had all the students when I did the boot camp. They basically created virtual machines that isolated their MES environment. So they put Ignition, MySQL, Python, PyCharm inside of a VM, and then they did the development in there. Okay. So we've gone through welcome and MES Bootcamp Accelerator. Let's get into introduction to manufacturing execution systems. All right. So in order for us to do that, let's talk about what MES or where MES is. Okay. So MES is where operations actually takes place. So if we look at how manufacturers actually work, like how manufacturing actually takes place, every manufacturer is basically the same. Okay, whether they're a one plant or whether they are a multinational, all a multinational is even if they're vertically integrated, that is, they're selling to themselves. They are still nothing but a series of manufacturing facilities put together at scale. Okay, so every manufacturer basically does the exact same thing. They sell stuff inside of a CRM. They use a CRM to manage the selling of stuff. Okay. They manage their customers in a CRM. They generate sales orders through that layer. They sell stuff at the CRM layer. Once they sell something, they plan to manufacture it or acquire it from distribution centers in their ERP, in the resource planning layer. The resource planning layer is where you convert where you input a sales order to generate a work order. Okay, a manufacturing order. Okay, and where there's 2 terms we're going to hear that are sometimes interchangeable: work order and manufacturing order, and sometimes they're two entirely different things. I'm going to explain the difference here later on. So we plan to manufacture an ERP. We may decide we are going to maybe I get an order for 100,000 widgets for a customer A, and I'm going to manufacture. I've planned to manufacture 50,000 of those at site A and 50,000 at site B. So now what ends up happening is that planning gets distributed to the 2 sites, and that happens at the MES layer. So now what happens is we take the plan to manufacture and we execute the manufacturing in the MES layer. We take the work order and we either consume the schedule from the ERP. Most of the time, though, we're scheduling in manufacturing or MES. So we'll take the work order, we will schedule it, we will start it, we will track all of our production events, and we will then move it to the next manufacturing operation and do the same thing all over again. Okay. Once we're done executing manufacturing, that is, all the stuff has been manufactured. While we've been controlling the plant and we've been controlling the assets, we then inventory it, we then ship it, we get paid for it, and then we do it all over again. MES, though, is the place where we convert a sales order that is generated and planned in ERP. We convert that into the actual manufacturing. Now, sometimes a sales order is coming from a replenishment center. It's not coming directly from the customer. It's coming. We're going to use the simple example here that I have a customer who orders N number of widgets of product number Y, and I'm going to manufacture it at site A, and we're going to walk through that entire workflow here with MES. All right. Another thing to understand about manufacturing execution. Manufacturing execution is the layer in an organization where IT ends and OT begins. Very important to understand. When we talk about IT-OT convergence, okay, MES is oftentimes half owned by IT and the other half is owned by OT. And the half of MES that is owned by IT is the stuff that contains proprietary intellectual property or information that came from the ERP. Okay, so that's your introduction to manufacturing execution. Okay. So let's take a look at a manufacturing execution system, an actual what is MES. Okay. So we're actually gonna go into the nuts and bolts. So like in the MES in the Bootcamp Accelerator, you are going to build a manufacturing execution system using an IoT platform, a SQL backend, using Python. You're gonna build MES. People ask me all the time, why is it, Walker, I can't buy MES? You know, you've seen me shoot these videos, and I've said, listen, you're always going to build your MES. Whether you do it in the beginning or whether you do it later, you're going to build. I hope to illustrate that point here with this manufacturing execution system for this actual manufacturer. Okay, so this is the manufacturer that our virtual factory for Prove It is based on. Okay, these are actual screenshots from the actual manufacturer. All right, what we're looking at here is the execution layer at the production line. Okay, so what we have here is we have order management in the upper left-hand corner on the screen. Okay, so I can select a work order from down below, and I can start my work order, and that is basically a rising edge. All the events that we see on this production line are going to be assigned to this work order that we're running. All of the OEE calculations, all of the downtime events, all of the creations of the roles, I'm going to explain here in a second, they all get attributed to this work order. And that work order goes back to a sales order, and that sales order ties to a customer. Okay, and I'm going to explain all that here in a minute. But what we're looking at here on the screen here, in the upper left-hand corner, is our work order. This is work order, and then it is production metrics. So how many linear feet we've actually produced on this work order. We have the quantity of the work order. We have how much is remaining. We have that order is active. We have the number. We have when it started, when we estimate it's going to finish, and then we have some actions the operator can take. We can end the order. We can categorize scrap any waste that's been attributed to this work order, and we can look at the approved scrap categorizations. And then we have our production metrics in the lower left-hand corner. We also have OEE, overall equipment effectiveness. I'm going to get into OEE in a second, like how OEE is generated, why it's important. You're going to learn how to do this in the bootcamp. But OEE is basically availability, quality, performance, and then those three numbers are multiplied together to get you your OEE number. So right now, this production line, Laminator 123, is running at 33% OEE, and you can tell quickly the two reasons. The machine has been down 37% of the time, and only about half of the material that we've produced is good, can actually go to the customer. However, when we're running, the operator's kicking ass because they're running at 104% of the rate they're supposed to run at. Now, there could be a correlation between running too fast and generating too much waste. And this is why MES matters. This is why OEE matters. Over time, we can compare the relationship between the quality, the percentage of the material that we generate that is good quality or bad quality, with our performance number. We may be super excited. Hey, man, we're running at 110% of our rate. However, every time we're running at 95% or faster of our performance, our quality number drops. The slower we run, the better material we produce. So maybe there's a problem with our standard rate.
This is why that's why Rick Bellotta doesn't like OE, by the way, because he uses that example.
Yeah, the issue. Yeah, he does. But the issue with not an issue with Rick, but you have to understand where Rick is coming from. Rick is an investor. Okay, so Rick puts his head in the mind of the executive. So Is OEE a good number for executives to make strategic decisions on? No, it is not. But is OEE a valuable number for driving improvement on the plant floor? Absolutely. All right. In the lower left-hand corner, we have our run data. In this case, we're looking at our downtime events. Or actually, in this case, we're looking at our schedule. But we can look at our downtime events, which I'm going to show you in a second. And then in the lower right-hand corner, we have a unique element. This is not one of the core four. This is the production and the consumption of work in progress, raw materials, and finished goods in the term of a roll, a production roll. Okay. One of the reasons this manufacturer would never have been able to buy their MES system off the shelf is this feature in the lower right-hand corner. This manufacturer takes raw film, that is 10,000 linear feet of film on a roll, and they print it, they laminate it, they slit it, sometimes they bag it, and they ship it to the customers. They're making flexible packaging that, like if you buy a bag of Doritos, they make the Doritos bag. They print it, they cut it to size and everything. One of the challenges this manufacturer has is when they create the first work in progress, that is when they print the film that's 42 inches across, okay? When they print that film, they can print 8 colors at a time. So if a customer has a bag that requires more than 8 colors, then they have to print it in multiple passes. So color 0, 1 through 8 can be on pass 1. Colors 9 through 12 would have to be on the second pass. Off-the-shelf manufacturing execution systems don't have that feature built in. None of them do. There's not a single manufacturing execution system on the planet that has that feature built in. You have to extend it. All right. Number 2, this manufacturer, sometimes when they generate the roll, when they produce a roll, all 42 inches of the film on that roll is going to one customer. But sometimes, you guys may know, when you buy like little thin bags of pretzels, that film, if you unfold it, that film is maybe 18 inches across. So they will print, oftentimes they'll print the same customer laid out 3 wide on the film and then slit it so that they can make 3 rows of bags. But many times they'll put 2 customers on the same set of film. There's no manufacturing execution system out there that allows you to do that either. You have to build that. And that is one of 1,000 examples I have come across in my career when it comes to MES. One of 1,000 examples. Okay.
Walker, just to give an idea, this was a pretty small manufacturer. Some people may think, oh, we're a small company, we're not ready for MES. This was a pretty small company when we first started working with them. How do you know when a manufacturer is ready for MES?
When you ask them what their problems are, and all of the problems they list out for you, what are you good at, what do you suck at, and what's missing? When you go, what do you suck at and what's missing? When all those things that they describe fall in the MES layer. So it'll be like, what we suck at is we suck at having a really good idea of where we stand at any given moment. So at 11 o'clock on a Tuesday, we won't know where we are to plan. We know how many production rolls we're supposed to generate, how many linear feet we're supposed to generate in a shift. But at any given time, I can't tell you where we are relative to the total number of linear feet we're supposed to generate. No one can. We'd have to go query that in a database. We'd have to go talk to a bunch of operators. That's an MES function. When they'll say, when we do fall short, we ran 100,000 linear feet. We scheduled to run 90,000 linear feet, but yet we still fell short. Well, that's because of the 100,000 linear feet I ran, only 50,000 linear feet of that stuff was good enough to send to a customer. That's an MES function. Okay. Our changeovers are taking too long. When they complain, we'll schedule 45 minutes for a changeover going from product A to product B, but the change order will take 4 hours. But when we go from product B to product A, it'll take 30 minutes. That's an MES function. Being able to analyze changeovers over time to optimize how we order our schedule is an MES function. So how do you know when you're ready for MES? when all of the problems you're complaining about are solutions that fall within the MES layer. Okay. All right. And then I'm just going to give you a couple of other examples. So in this lower left-hand corner in the schedule, these guys are they're able to select the job jacket. They can select a row, select the job jacket, and it'll show the actual job. By the way, again, this job right here, this is the actual sales order. So this is not the work order. It's not the manufacturing order. This is the job jacket that was generated by the customer service representative. This is what the customer is paying for. Okay. There is no off-the-shelf MES system that allowed us to build this. This had to be built. Why? Because this job jacket exists only for this manufacturer. What you are looking at right here, the way they lay this out, the way they sequence the manufacturing steps, is the ink ready? Is the art ready? Have the plates been manufactured? Have the plates been installed? Has a supervisor approved the art and the ink and the installation? Those steps there, that is unique to this customer. There's no off-the-shelf MES system that allows you to build that allows you to create that. Okay, we had to build that, no matter who we went with. Okay, this is downtime. Downtime tracking, Zach's going to show you in a couple of minutes, but these are the actual individual. We had a roll change and a butt splice at 9:55 to 9:59 for a total of 3.85 minutes of downtime. And I'm going to go over downtime in a second. And then we have a drill down in this individual process data here. So this is the generation of the roll. What I did was I opened the roll. I went to material management to look at the individual materials that are assigned to any of the individual rolls that were created at a specific time while they were producing. This is an MES function. Again, this doesn't exist. There's no MES system that creates that off the shelf. It has to be built. This is the dashboard that goes over the production line. So when you go out onto their plant floor, every single one of their assets has this dashboard above the machine. This is their schedule. So we're going to go over scheduling here in a second. This is MES. This is their schedule left to right. So the printing press is supposed to run this job right here, 122812. Okay, it's going to be a one-pass print. Here's the problem. It's not ready. This one was supposed to start on December 1st at 11:38 in the morning, and it's still not ready. And the reason it's not ready is because the only thing that's been done on this job was they had a sample PDF of the art. Everything else hasn't been done. The film is not available. The plates aren't in inventory. The plates haven't been mounted. The ink is not ready, and nothing's been mounted, and it hasn't been looked at by a supervisor. So now, instead, the next job that they run is a job that was scheduled for December 3rd, yesterday at 5:13. So what do we know right now by just looking at this schedule? This job was supposed to start at 5:13. I don't know if you can see that, but it says December 3rd at 5:13 p.m. It was supposed to start. I took this screenshot December 4th at 10:23 in the morning. So they are nearly one full day behind schedule on this laminator or on this press. This is what their schedule used to look like. How far ahead are they, or how far behind schedule are they if we're just by looking at this board? The answer is no one fucking knows.
No one knows.
No one knows. So when they said we don't know where we are according to plan, it's because they were looking at this. Where are they according to plan? They're nearly a whole day behind schedule. They're actually 18, 19, they're 20 hours behind schedule right now on this press. And then what is the culmination of manufacturing execution? So what we're looking at is a series of reports. So this is the press work order check report. So what this is the event for these are the work orders over here. So 211, 711, 281, 511. These are all the check events. So this was when they were coming in and checking off these in. When did they approve the film? When did they approve the PDF? When did they approve the plates that were in inventory? When did they say the plates have been mounted? When did they say the ink is ready? When did they say they were mounted? Those are all these individual events. That's an MES function. Guess what? Not a function you can buy off the shelf. And then the approval checklist is the order of the work orders that were approved by the supervisors once all those checks were completed. This is the details. These are the individual details and the inputs from those supervisors. And then this right here is a completed job. So this right here, the work order for the customer was manufacturing 2850, M2850. That's actually a test run. They're testing a product for a customer before the customer buys it in bulk. So the sales order was M2850, which in this case they call a manufacturing order. There were 4 work orders. There was 1 work order to print it. There was 1 work order to laminate it. There was 1 work order to slit it. And there was 1 work order to pack it. This is the genealogy of M2850. And that is an MES function. All right. So that is MES. When you ask, what is MES? That's MES. However, if you go to another manufacturer, if you ask me to show you a bakery we did an MES for, or you ask me to show you a, let's do this one. So if I show you, this is a high pressure fuel pump, you'll notice some similarities to what you're seeing here. Okay, some similarities, downtime tracking. But now what are we looking at here? This is unique in the lower right-hand corner. This is the active part number and the cycle time for a fuel pump running through a fuel pump manufacturing environment. And you'll notice that, and the reason why is because in this manufacturer, in this case, this manufacturer doesn't run one product at a time. They can run many products at the exact same time. The fuel pump that comes into cell A could be part A, and then the very next fuel pump could be part B. You could literally go A, B, A, B, A, B, A, B. So that's unique to this manufacturer, okay? And there were features that they were looking for that were very unique to them. Like, for example, this in the upper left-hand corner, this is the state of the process. Red means a cell was down. Red, the second bar here is whether the production line was down, and the rest is whether an individual cell was down. That was unique to this customer because the production line could be down, but you could have multiple cells still running. So there were 16 cells that made up this one production line. The line itself could be down. We could be tracking a downtime event, but individual subcells could still be running because every cell had surge capacity. There were multiple fuel pumps in between each cell. So in a short downtime event, a chokate, an event that was 10 seconds or shorter, you could have 8 of the 16 cells stop, but 8 of them still keep producing. Okay.
Look at all those micro stops, by the way.
By the way, that
was
was
the ones you're missing without
those micro stops were the difference between that was the $25 million return for those guys. All right. Any questions so far that popped up before I go into the core 4?
Yeah. Someone asked, will this be recorded? Yes, this will be recorded. It'll be up on the channel. You can share it. What is the difference between MES and MOM?
Manufacturing operations management sits directly above execution. So MOM and MES oftentimes are very interchangeable, but MOM is manufacturing operations management. It is the layer directly. Think of MOM as the layer that manages MES. So, and in fact, I think what we'll do is during the accelerator, we'll do a 15-minute lesson on the difference between. Most of the time, MOM and MES are interchangeable, but if you dig deep enough, MOM is a layer that sits directly above MES and manages MES.
Finite capacity scheduling is normally a standalone application, but live in the MES layer. Scheduling is part of the MES and always has been. There's just a comment. Nemanja said,
by the way, that's absolutely true. Scheduling is an MES function. Guess what? Vast majority of manufacturers try to schedule an ERP first, and they fail.
In which system we define all machine phases, statuses outside of production? For example, when the machine is under maintenance or any other planned stop.
We'll show you that here in a second. That actually happens in the CMMS system and in the MES system combined. But we're actually going to go, when we go through Core 4, we're going to show you how this is all put together. We're going to do a high level at 10K, and we simplified it. That way we don't lose anybody. But those of you who have advanced MES knowledge will see where the gaps are. But we'll go into that as soon as I jump into the Core 4. I'll answer that one.
Awesome. Alan said, where does EBR or electronic batch records come into the equation?
So EBR would be essentially traceability, track and trace. So which we're not going to cover here, but essentially here, I'll show you what EBR is to this manufacturer. So EBR is to life sciences as EBR is to life sciences as our manufacturing order confirmations are to this flexible packager. So this would be this right here.
EBR.
Yeah, so this is a transaction. So this is event 1, printing. That's 1/4 of the it's the manufacturing order record. So in life sciences electronic batch record, this would be 1/4 of the batch record. And then we would add this to give us 1/2 of the batch record. Then we would add this to give it 3/4 of the batch record. And then we add this to give you 100%.
Nando said, I do not have any programming or development skills, but I am part of the mastermind. How can I benefit from the training? Will I get support if I get stuck? I answered that in the question, but I'll answer it here.
The answer is yes.
That's where I come into play. We're going to basically walk you through as if you had no development experience. So if you fall behind any of the weeks, that's what the weekly group coaching calls are for, to help get you caught up. And the demo I'm going to show you here in a couple of minutes, I built that in like 2 hours. And so if I could build it in a few hours, I'll show you exactly how to build it. So you'll be able to, and then with the tools that we have today, like I was going to ask Walker, like if you were to build this again today, but like, let's say using Tulip for the front end, how much easier would it be?
Oh, I mean, front end development.
You could bolt Tulip on top of this.
Correct. Yeah, correct. So if you look, hold on, let me show you.
So like, I mean, composable MES.
Yeah. So if you look at the underlying data, right? So if we look at, we're looking at the actual individual presses. So that dashboard, what you see, this dashboard right here, okay? This dashboard namespace. If I go back and I show you this dashboard here, everything you see on this screen is inside of this informative namespace. Okay. Everything you see in the schedule falls in that scheduling namespace. Everything you see in role consumption, running role information, role info, and role production, that's everything you see over here. So what you see there and what you see in this box, this is inside the schedule. This is inside the line and OEE namespace. Saying everything over here is in line and OEE. This is all inside schedule, and then these are all reports. If you look at all the underlying structure, this is 40% of the work. Building, press, lamb, slit, bag, building the underlying namespace, the events, event tracking, creating your master data model. That's maybe 40% of the work. The bulk of the work is building the front end. I mean, to build this dashboard, this was certainly, to get it to this point, this is weeks worth of work. I remember when I built, this is MES Lite. When I built this took me 4 fucking months to do this front end. Like I built this in 2017 or something. This is vision. Now that they still use this on the production line because we did this customer in 2018. But today we wouldn't put this front end today. Today I'd use Tulip, I'd use frameworks. I might use Ignition Perspective. I would use the Perspective because I can generate essentially a JSON that will generate this screen for me. You know what I mean? I'll have prepackaged CSS and then a JSON that the view would consume, and it would build the screen without me having to build it. Using Java Swing, this was the bulk of the hours was doing this. So it'd be much easier using a lot of tools that are available today to do the front end. The back end, you're building it exactly the same way.
And in the bootcamp, we're teaching you the fundamentals to understand it at a core level. Then you can use tools to make it easier. But like someone asked, are all the front end components and views we are seeing here made in Ignition? Yes, this is all Ignition. Some of the components are pre-built. Some of them are custom built. We'll get into that.
All the UI that you're viewing here is Ignition. You do not have to use Ignition. Okay, just so we're clear, you do not have to use Ignition. We chose to use Ignition. So we chose to use Ignition for the bootcamp because everybody can download it without having to talk to somebody. You can install it in 3 minutes, and at its base level, it's drag and drop. If I could get, a lot of what I was doing was I was generating the namespace, the tags, and then I was giving the students a backup file that was available on GitHub. They would download it, import the tags, and then they could just, in Ignition, they could grab a tag and drag it onto a screen. That was part of the reason we chose Ignition, was because Ignition at its base level had a drag and drop capability, but I could also build anything with it. Ignition is not important here. Ignition is the IIoT platform, but it's not, what we're teaching is not critical to Ignition. Ignition is not critical to what we're teaching.
I'm having difficulty making management understand the difference between MES and ERP. What are the key points that ERP cannot do? Hence, MES comes into play. Many believe SAP can do everything.
SAP sucks. Let me say this real quick. There is no greater. Let me say this real quick. Let me get over here and let me make this perfectly clear. You can record this as a short. I will say it again. Okay. There is no greater hoodwinking that has taken place in our industry. There is no greater travesty than SAP. SAP is a $50 billion company, okay? And SAP has ripped, let me say it again, they have ripped off more customers than I can count. Here's why. SAP continues to sell something that they cannot deliver on. Okay? Here's the difference. Here's why. Here's why. Now, is SAP a very powerful tool? Absolutely. It is what we refer to as, under the hood, it is in fact what is known as an ORM, Object Relational Management Tool. It allows you to create an object and then relate them together. Okay? There is a reason that when you buy SAP, it takes years to roll out, because you end up having to build your business inside of ERP as a series of objects. You have to map your business. That's where your master data model comes from. Here's the problem with that, okay? By doing that work in SAP, you are essentially deciding for all time how you're going to do things. And if you're going to make a change on how you operate on the plant floor, which, by the way, for all of us who have worked in manufacturing, we know that there is one fucking truism in manufacturing, and that is things will change. Production is king. No matter what, you will get the shit out the door. If it means that I've got to cut a machine in half and route, I'm gonna do the production on the first half of machine A and the production on the second half of machine B. That's what I'm gonna do, because production is fucking king. Okay, so just because you created some rule in SAP doesn't mean that that rule is not absolute. So why is it that manufacturers make this mistake in ERP? Well, the answer is because the people who sell ERP they are the best salespeople in the world. They're equivalent to people who sell in life sciences. They make hundreds and hundreds and hundreds of thousands of dollars a year, and they have mastered the art of extracting tens of millions of dollars out of executives. But history has shown us over the last 30 years, there is a whole graveyard of companies who were dissatisfied with their ERP implementations. And then they get left holding the bag. Manufacturing execution. Here's why manufacturing execution is so important. It's where the business actually takes place. If you are an ERP-centric company, manufacturing execution is where you enforce what's in ERP. If you're a manufacturing execution-centric company, ERP is where you reflect what happened on the plant floor.
That's the key.
Okay? That's the key.
Your business doesn't happen up here. It
doesn't happen in ERP. It happens on the plant floor. You must have a way of capturing what actually happened. And there is no way for you to predefine every single scenario, which is what ERP requires that you do. All right, let's get into core 4, and then we'll have Zach do
more
his
questions at the end.
Yeah, and then we'll do the rest of the questions at the end. All right. So let's go into core 4. And let's start with work order management. Let me zoom in here. So what is work order management? A core 4 function of MES. So first off, work order management is the conversion of a sales order into manufacturing. Okay, that's what work order management is. So there are some components. You know, you have the sales order. That is what we sold to the customer. Sometimes the customer is ourselves. Sometimes it's a warehouse that we own. That's our customer. But there is a sales order where we have the order, the ID, we have who the customer is or the type. It could be an internal or it could be a customer name. We have the quantity and we have when it's due. Okay. This is the starting point for all manufacturing. This is the starting point for all manufacturing. You don't just manufacture shit. Okay. Number 2, you have a work order. A work order is a component where we take the sales order and we break it into simpler elements. So I may have one sales order that gets broken into 2 work orders. Okay. Work order A may go to site A and work order B might go to site B, or work order A and B may be us breaking out the sales order. Let's say I get an order from a customer of 100,000 widgets. They want the whole thing delivered they want everything is due 6 months from now, but they want half of it in 90 days. So what I would end up doing is I would break that into 2 work orders of 50,000 units, one due 90 days from now, one due 6 months from now. So the work order is the second element in work order management. And then there is a third optional element, but it is used very commonly, and that is the manufacturing order. So I might take a manufacturing order for site B, and I might break it into 3 individual manufacturing orders. Okay? So manufacturing order number 1 is tied to this work order. It represents step A. So in this case, if we do print, laminate, and slit, step A would be the printing step. It would run on asset A. It would have a quantity, and it would have a due date. And then the manufacturing order number 2 would be tied to the same work order, but it would be for a different manufacturing step. And it would run on asset B at a specific quantity, and our quantities might change. So I may, in step A, it might be linear feet in and linear feet times 2 out. It could be linear feet in, pages out. Okay? And
this would be your electronic batch record if you're in life sciences.
This would be, well, your EBR would tie back to your work order, okay, not your manufacturing order. And then you'd have step 3. Now, let me say something real quick. When it comes to work orders and manufacturing orders, there's what ISA says that you should do. ISA says we should have both work orders and manufacturing orders. That comes from the mom side, those of you who asked about mom. ISA says we should have work orders and manufacturing orders. Not everybody's got work orders and manufacturing orders. Some people just have work orders. And so it goes sales order to 3 work orders. 1 for step A, 1 for step B, 1 for step C. You have manufacturers that don't have work orders at all. They go sales order to manufacturing orders. Okay? Not all manufacturers is the same. Want to know why? Because everybody started with Excel and not everyone studied ISA. There are people who started manufacturers who had never been in manufacturing before ever. Or they had been in manufacturing and they thought the way manufacturing was doing it was stupid. We don't need work orders. We can go sales order directly to manufacturing order. Okay? All right. So the next thing is work orders are used in scheduling. They're used for event tracking and they're used for reporting. All right. The second element of the core 4 is scheduling management. So this includes schedule creation, schedule optimization. In which order should I run things? Should I do on my printing press, for example? Should I go product A, product B, product C? Or should I go product A, product C, product B? Because if the changeover time between A to B is 90 minutes and B to C is 90 minutes, but the changeover time from A to C is 30 minutes and from C to B is 45 minutes, our optimal schedule would be A to C to B. Okay? We also, another element of scheduling management is resource allocation. Then we have event tracking and reporting. So what do we do when we're scheduling? Well, what we do is we take, with our schedule, we connect back to our manufacturing order. Grab this. We go back to our manufacturing order and we create a schedule. So let's say, for example, for asset A, I have one manufacturing order, but I've decided I'm going to run it and I'm going to print it in 2 runs. So I'm going to have 2 items come out of in the schedule for the same manufacturing order. So I'm going to have 2 schedule IDs, 1 manufacturing order, both run on asset A, 2 different quantities, 2 different scheduled start times, 2 different scheduled end times, 2 actual start times, 2 actual end times, and 2 setup times. So work orders are used in scheduling. So scheduling is the second of the core 4. All right. The third is downtime tracking. And I'm going to go ahead and explain downtime tracking, and then we're going to have Zach do his demo. All right. Downtime tracking is a subset of state history. So downtime is just a list of events where the state, the value of the state was equivalent to a downtime event. But we have different types of states, okay? So here are the elements that make up state tracking. We're always going to have a state register. Oftentimes, this is going to be, in a perfect world, this is a register running in the PLC that's equivalent to an integer, and that integer we can use against a lookup table. So if the value is 0, we know the state is stopped. If the value is 1, we know the state is running. The asset is running. If the value is 2, we know it's an e-stop. If the value is 3, we know it's blocked. If the value is 4, it's starved. 5 is changeover. 6, 7. You know, these right here are the relative standards. When you see 0 through 10, it's generally those actual states. So that's the actual standard that we see. And then 11 through 1,000 would be the individual machine states for that machine, often tied to an alarm. So let's say it's in an alarm overheat. The value might be 996 is the state register, and that means this motor is overheated. Okay. 1001 to 9999 is oftentimes business system states. That might be this asset is in a trial state. So that is, we do not produce any production material on this asset. The business system state is in trial mode, or it's in validation mode. Okay. And then states and modes are interchangeable oftentimes. Most of the time, state and mode are combined together. In a perfect world, you will have a value for state and you'll have a value for mode. Okay. All right. So you have a state register that we monitor, and we store every state into a history table. What is the state value? What is the start time and end time? Now, this is a very simple representation. Zach is going to show you a little more complex one. Okay. We also have a state reasons table. Let me explain this here for a second on the left-hand side. Wherever anything you see in red means that if the value is that, if we are that value in this table, when I go to look for my downtime tracking, I'm going to say, go select from this state history table all the red ones. Add those together, put them in this table, and I'll see all the downtime events. But I also have green and blue and black events. But those are not downtime events, so they don't come back in downtime tracking. Downtime tracking is a subset of state history. All right, and with that, I'm gonna pivot it over to Zach, and Zach's going to show you a quick demo he built.
All right,
And then
everybody.
and I'll do OEE and we'll answer questions.
All right, everybody. Welcome to class. I hope you guys all had a chance to view the theoretical instruction by Walker Reynolds. Now we're going to be diving into the hands-on application. So let's dive into it. This is lesson 0 for
0.0.
the MES. This is the lesson 0 for the MES Bootcamp. All right, I just had to reset my trial. So I got this up and running yesterday, and I just wanted to show you guys, if you have no coding experience whatsoever, we're going to walk you through building that up. And like Walker said, we'll give you the backup files. If you get stuck, we'll kind of get you caught up each and every week. So at the end of the 8 weeks, you'll be able to walk away with a custom built MES that you can adapt to your business. We're going to show you the features, and you can kind of get the concepts and extend it and apply it to your business. So I'm going to show what I've got built here. So essentially, this is a production line, a simple downtime tracking application that you could build in like a few hours. So what I'm going to do here is I have this little drop down to select one of my lines, and right away I have these components that pop up that show all of my, on the left table here, we have all the downtime events. And on the right, we have cumulative downtime seconds. So production time, planned downtime, and unplanned downtime. Right now, I just have those 3, but you can extend that to any number of different downtime reasons. And you could drill into,
you could do like trial. You could break that down into trial. You could break that down into validation. You could break it into anything.
The idea here with this component, this is this up top here, this downtime vision, you would be able to see the actual bars here. I haven't gotten that part working yet, but that is pretty straightforward to get going. There's just like some complexity with the colors, but there's, when you're going through this class, there's going to be some parts where you're going to have to try to do it yourself a little bit, and then we'll get you caught up at the next class. But there's the items. Here's the scheduled downtime events. Here's the unscheduled downtimes. But if you see, this drop down right here is super dynamic. So when I click line 2, there's the second line over here. This is the UNS Enterprise Site Area line. So if we look at this edge, this is our edge namespace. This is coming from the PLC. And here's our OEE UDT. I'm going to dive into that in a second and show how this is actually working. But just as a quick example, if we simulate a downtime event, boom, there it pops up on line 2. Notice how there's no downtime seconds yet, because it doesn't know we're currently in that event. It doesn't know when that event ends. If we pop it back over into production, this is set on a 5-second. Yeah, so there we go. We just had this new downtime event for 12 seconds. And again, you could extend this to like double click to drill into it. But at a base level, I just wanted to show you guys how quickly you can get up and running. The key here, I'll show you in the back end and the Python scripting, is storing these events. You can extend it to add different reasons. You could add different visualizations, but if you're not tracking your downtime events, you can't do any of this.
If there's anything that you need to do yesterday, it is you need to start tracking state history. If you track state history and you have a state reasons lookup, then you can track downtime. And anything that you're going to want to do in the future, machine learning, predictive analytics, it doesn't matter what it is. Anything you want to do in the future, calculate OEE, optimize your schedule, whatever it is, you will need state history. You need to start tracking it yesterday. Go ahead, Zach. Sorry.
And most of you guys probably have an IIoT platform. If you don't, you can get an open source. You could do this in Node-RED if you want with the scripts I'm about to show you. You notice I actually just fat fingered number 10 here, and that's showing up as an unknown state. So, all right, but let me show you the UDT first, and then we'll show you the back end. So under the UDT definitions, we have this OEE object. Well, actually, real quick, let me show you how, based on this being a UDT and self-referencing, if I wanted to extend it and create a new line, I can just copy this, paste that whole folder. Now we have line 4. And in a second here, this will update to show, boom, there's line 4. Now I could start, I could start tracking my downtime events on line 4. So how do we do that? We do that through this UDT definition. There's many different platforms you could do this in. You could do this in Litmus. You could do this in HiByte. You could do this in frameworks. But to the way that you would do this, this is a data and information model. So under OE,
depending upon what platform you're in, it's going to be called something different. But all we're doing is data and information modeling here.
So under the OEE object, the first most important tag right here is the current state. This is an expression tag that's referencing the state that's from the edge. We do that so it brings it in and it normalizes it into this OEE data model. So this reference, this expression, this dot nomenclature means starting at the current location, go up 2 folders, and then go up to the parent folder, then go down into edge state, and just bring that in here. Under dispatch, we do the same thing with this state tag where all of our scripts run. So that just references that current state. And the event scripts, whenever this tag changes, we have a tag change event script. This is what does the magic, right? And I'll show you the back end after I show you the script here. But effectively, we take the new value and we write it to the state start time. So if you see, I'll show you that in a second. But you have an active visualization for what the most current state when it started and the active runtime in that current state. Then we add 2 updates to the database, to the state history database. And let me make this a little bigger so you can hopefully see the full query here. Like I said, I did this in a couple of hours, so it's not super pretty or it doesn't have comments or anything, but I'll just show you. Here's my query, here's my arguments, and here's the database we're running that query against. So we're going to update the state history table, and we're going to set the end time equal to right now, where the topic is this tag path, and the end time is null. There's only the most recent record is null because it doesn't have an end time yet. Then we're going to insert a new record into the state history with the current topic. That's our tag path. Wherever this object is, that's our, it's essentially our tag path, or, if you're using unified namespace, it's your topic path, whatever the integer value is of that state, and then the start time, which is now. And then we insert that new record. And then up here, we just did a little string manipulation with Python. We didn't want to have the OEE state dispatch state portion on there on the tag. We just wanted it to end at the current line. So that's just a very simple, you could use ChatGPT to do this stuff, right? To write this little Python script. Hopefully you know how to do this. This is not too difficult, but I did actually run into I was having trouble with one of my updates. I had a misspelling. I said update. And so I was like, and to try it in the tag, to write a script in a tag event change is actually a little bit harder, because if it has an error, you don't really see that in the console. So I would copy this, I paste it into the script playground to test my scripts before I put it into this tag script area, tag event change script. And I was like, I can't get it. I got stuck. So I just pasted the error message from the script playground into ChatGPT. And it's like, oh, you meant you have a misspelling on update. I was like, oh, okay, great. So the fact that we have these tools really helps aid the development. So last but not least here, I'm going to show you the back end with the database query browser. So this is the table that we built for the state history, and we could just select the most recent records. And as you can see, here's our topic with our different production lines. This is when this state happened. There's 3 records, or now 4 for line 4, for the most recent, the most current state, and then whatever that state value was. Obviously, if you do database normalization, you could have another table that is our state lookup table. What is state 1? What is state 0? But just to get started, I had it real simple. 1 is running, 0 is planned downtime, and 2 is an unplanned downtime. These ones I fat fingered are now showing up as unknown. Let me show you those queries right here real quick.
And one other thing real quick while he's bringing that up. In a very advanced scaled MES system, you're going to use UUIDs in these records. What we're showing you is very stripped down structures so we can teach how to do state tracking, right? Without it being convoluted.
So this was probably the more to do this to get this cumulative downtime right here for whatever. Let me pull up one that has a little bit more info. To get this cumulative downtime, it's a pretty straightforward query, but I like I said, I did use ChatGPT to help aid that development. because I knew what I wanted, and it just, it helps with the formatting. And let me pull up the query here for this data set topic. So it's going to, and it formats it nicely for you and everything. So it's using a case statement. So when the state is 0, it's going to show up as planned downtime. When the state is 2, unplanned downtime. State is 1, production time. It added in this unknown state, which ended up being pretty useful. Just, on this live demo here, I accidentally hit 10. So now it's going to show all of the time on unknown states.
Otherwise,
and then everything,
those wouldn't have shown up at all.
Exactly. So, but yeah, like I've written queries like this, but this is something that it used to just take a lot longer. Now we're compressing what used to take months or years down into just 8 weeks to get you guys going. Anyone can do this, right? And if you guys get stuck, I'm going to be there every week on the call. You can bring your questions and we'll help guide you along through the cohort. But basically we're going to sum the end time minus the start time as the cumulative seconds from the state history, where the topic is. This is where we're bringing in that parameter from that dropdown, whichever asset we're looking at. And we're going to group it by the topic, which is our tag path, and the category, which is this case as category. And that's pretty much how you would get this simple application going in an afternoon.
Nicely done. Well, we're gonna jump to questions here in a second. Let me go over the last element, which is OEE. But I wanted to talk about how does all this get back together? How does this all work together? So everything that we've done, everything I showed you over here. So the core 4, how does the core 4 work together? Well, the core 4 works together where on each asset, I'll have a schedule that'll include setup time plus a manufacturing order plus the product plus our standard rate, which is going to be used in the OEE calculation, which is why I'm showing you right now. We will have a standard rate either for the asset itself, or we'll have a standard rate for the product that we're producing on that asset. We'll have an order start time, an order end time, and an order total time. This is going to be used to calculate performance in the OEE calculation. We're going to have a state namespace that contains all of our state history. This will be used to calculate downtime tracking. And it'll also tell us which states are going to be used that will ding us on our performance number. Like, for example, if we're blocked or starved, you'll notice when we're blocked or starved, we say that's a run state. So that doesn't count as downtime. It means we're in a blocked state. We're notifying that we're in that state. We can see how often we've been blocked, but the number that's going to get hurt in the OEE calculation is the performance number, not the downtime number. By the way, this is a huge mistake that we see manufacturers make. They will make blocked and starved an actual downtime event. Downtime events are supposed to indicate that we have a problem with the asset itself. Okay, so that's why most of your machine alarms, they go to actual downtime, right? Our counts, in-feed, out-feed, and waste are the 3 counts we need in order to be able to calculate OEE. And then the general KPIs we end up with by using the core 4 are availability, quality, performance, and OEE, and then a bunch of other reporting that I showed you in the what is MES. All right, let's quickly go over OEE in layman's terms. So what is OEE? And then we'll answer questions. So OEE, why is this important? Well, OEE is a standardized efficiency calculation for production equipment. Okay, it takes into account the availability of the equipment, the quality of the goods produced by the equipment, and the rate of production of the equipment to determine whether it's operating effectively or not. OEE is a valuable calculation because it abstracts away the differences between machines, leaving us with a KPI that can be used to contrast unlike equipment and operators and processes in apples to apples comparisons. So for example, I want to show you, these are just examples of showing OEE, but I want to show you, if I've got an OEE number of 47% and my target is 82, well, that just tells me I'm inefficient, but it doesn't tell me why. OEE, if I look and I see my quality is 99.88%, what that's telling us is that when we are running and we're producing goods, we're producing good goods. So that's not the problem. The problem is we're producing good stuff. The real issue is that the machine isn't available enough for us to produce what we need to produce by the end of the shift. So we're producing, if our OEE target is 94%, which by the way, that's a fucking enormous number, 94%. If you have 80% OEE, you're operating in a world-class space. If I want to operate at 80% OEE, I'm never going to get there if my machine's only available 56% of the time. So what I would do is I would say I've got two problems here. When we're running, my machine is breaking down 43, almost 44% of the time. It's not running. When we are running, we're only producing 85% of what we should. So I've got two issues. I've got an availability issue and I got a performance issue. But I'm going to focus on that availability issue first. And the very first thing I'm going to do is I'm going to go look at my downtime tracking. I'm going to see what are the reasons I'm down. So I'm going to go and I'm going to look at these downtime events. And I'm going to go, oh, in this case, wow, we're down a lot for roll change and butt splice. But the big one is wash down and parts changes. Now, this customer happens to say that a roll change and a butt splice, which is something they must do, that's a downtime event. And the reason why is because a butt splice should take 0.5 seconds. But oftentimes it takes up to 4 seconds.
Minutes.
Yeah, that's what I mean. Sorry. It should take 0.5 minutes, but it oftentimes takes up to 4 minutes. Sorry. Thank you for correcting me. Okay. That's why OEE matters. Okay. All right. With that, let me go back to the webinar. Let me talk real quick. Homework between now and session 1 of the Accelerator. Let's talk about that real quick, and then I'll answer questions. Those of you who are in Mastermind, the Accelerator is already included. You can take the Accelerator, do the boot camp, but Mastermind gets you everything. If you're not in and you want to do the Accelerator, you'll get the boot camp plus the Accelerator, right? So you can do that. You can sign up for that at IIoT.university. I think there's a little banner at the top or something. But if you're not in Mastermind and you want to do the Accelerator, you can sign up for that at IIoT.university. So anybody who's going to ask that question, that's how you do that. If you're in Mastermind, all you have to do is you're already going to have access to it. That product you'll already have access to. You'll just select on it. I've given you the schedule here. You'll be in that first session on January 7th or January 9th, 7th. If you want to take it and you're not in Mastermind, you can go sign up for it at IIoT.university. All right, with that, questions?
Yeah, and one of the success stories, this was a person who was in Mastermind, but he went through the boot camp. He was rolling out an MES for the company he worked for. They had a schedule of like 6 months to roll out OEE at 5 different facilities over 6 months. And in 2 months, they rolled it out in a dozen facilities. So, this is the type of change that we're talking about by what. And my question to you, Walker, is why would you, a lot of people would see what you built and say, why don't you sell that? Why do you teach people how to build that?
Because here's why. Why did we do the boot camp? Here's the simple fact. There were 700, right? We had 700, 800 people sign up for this webinar, right? It's 800, whatever the number was. It was a crazy number, all right? Of all those people who signed up, 90% of them don't really know what MES is. So part of the reason we did the boot camp was so that we could teach you the basics. Like what we just taught today, if you didn't know what MES was, you have a much better idea of how MES actually works in just 1 hour. Okay? But MES is actually quite complicated. There's a reason that there aren't that many MES engineers out there. And it's not because manufacturers don't want digital MES. Manufacturers don't have digital MES because there aren't enough engineers to build it for them. And so what do? They try to buy it off the shelf. And when they buy it off the shelf, they get ripped off. They only end up with a fraction of what they actually want and need. They end up with a fraction. And it's in a silo. And it's limited. Right? I mean, one of the things I remember when PTC invited me to Maine. They invited me to Maine to look at their new product that they were coming out with called Manufacturing Apps. This was after the ThingWorks launch. They came out with these tools called Manufacturing Apps. And one of them was like operations planner, and one was manufacturing planner, and I can't remember what they were called. There was 3 of them. But one of them was an OEE calculator where you could calculate OEE. And the first thing that jumped out at me was that they had 6 possible states the asset could be in, and there was no mechanism to create your own custom state. So there was no mechanism for you to say, oh, wait, I have states on this machine. It's like, for example, I worked with a manufacturer that had, one of the things that they had written was a standard they had 500 alarms on every single asset. And the alarms were ordered in the order of priority. So if you ever saw, if they had 5 alarms active, alarm 1, alarm 31, alarm 250, and alarm 500, the actual alarm, that the reason the machine was down was alarm 1. They actually ordered it in the order of priority. You could have never used ThingWorx manufacturing apps, PTC's manufacturing apps, to do the OEE calculation for them and use all the alarms they had. Okay, so part of the reason we do this is we're trying to teach people MES from the ground up. Why is it we don't sell it? Yeah, okay. We have MES Lite. We have it. It's called MES 4.0. We've had it for years, and we do have customers who use our MES, but we don't sell it and we don't market it. We keep it as a solution that we use to help manufacturers. That's what we do. What I would much rather is teach people how to build MES, because I think that's how manufacturers will benefit the most. Because at the end of the day, your manufacturing execution system is going to grow with your business. It's going to change with your business. And that means that you have to have people on site who can help it change. And the only way you can do that is if you can teach them how to build it from scratch. So that's why we do this.
Awesome. All right. We had a lot of questions come in about this. I can answer just real quickly, but
what's the question?
Is OEE over a shift, hour, or day, or what is typical? Typically, you're going to be looking at it over the manufacturing order, right?
So OEE, you can pivot OEE however you want to. If you build the MES system correctly, then essentially what's changing is the query that returns the results. And depending upon which query you use, OEE is by something different. It's in the where clause. So
you're either grouping by manufacturing order, grouping by
schedule, grouping by asset, grouping by operator, grouping by product.
So by tracking those individual events, you store it, you can show it however you want.
The most common way when you're looking at OEE on an operator screen, you're looking at 2 operating. You should see 2 numbers. You should see the work order OEE. So what is the OEE on the production run I'm doing right now? And what's the OEE for my shift? The most common is you have 2 numbers there. It's being pivoted 2 ways. But on the reporting side, you're pivoting it 25 ways to Sunday.
Kara asked, will this MES program let participants build the MES based on the real machine, or is it just only a simulation on the software? If you have access to the machine, I encourage you to use real data, right?
There's an actual simulator. So in the boot camp, there's a simulator we wrote where you actually turn the simulator on and off, and it's simulating the process. And then
I was going to write one, but I just ran out of time.
Yeah, the beauty of the simulator is that it also gives you the ability to define the rules that you want to test. So if you want to see how an MES system behaves under certain conditions, the simulator gives you that ability. However, with the MES system you build, you are not tied to the simulator. The simulator, there's only 4 data points for feeding in from the simulator: in feed, out feed, state, and waste. But you just decouple the simulator and then you plug the asset into in feed, out feed, state, and waste. And now you've got live data from the asset itself.
Yeah, someone said, are you calculating on a single asset or multiple assets at a line? Both. Again, it's however you group it or however you query it.
Yeah, how you query it. Yep.
Are there any other questions that we missed? Vaughn, have you seen any? Someone asked why I've been using MySQL. Apparently MySQL's kind of fallen out of favor in the last few years. Kind of showing I'm dating myself a little bit by going that route. But what do we use in the bootcamp? My MS SQL?
We use MySQL. Here's why we use MySQL, guys. Time to value. I can get MySQL spun up. I can get Access spun up, and I can get my schema built faster in MySQL than I can in any other database. If I move to production, then I'm converting all my queries to Postgres. Like in production, I'm going to use Postgres. But the startup time for Postgres is longer. So when you're teaching classes, you're going to use the thing that gives you the shortest time to value.
Oh, this is a good question. If the only technical department in a company is IT, which controls ERP configurations, and in this case, Infor-LN, which with no MES, basically ERP outputs production order to the floor, then the need for MES is obvious, but there is a new department to be built to handle that. How should we think about this and sell to executives?
So what you do is you start with somebody on. So IT is the border. So that middle level at MES. So in your case, IT ends on the bottom side of ERP, and OT begins on the top side of SCADA. Okay, that's what you've got. What you're going to do is since the work order is already on the plant floor, what you're going to do is someone who works on the OT side is going to pick one asset to put an MES system on. They're going to consume the work order from Infor, and they're going to build MES, track state, and then they're going to and then what you're going to do is go to the decision makers and go, do you want this? Like one of the examples, the client I showed you here, the client did not know that they needed MES. So in 2018, they hired us to just connect their equipment. We were a Kepware partner. What they wanted was they wanted us to connect their equipment using Kepware because we were in Dallas. They looked up Kepware partners based in Dallas and called us. We take a look, and I'm like, oh, you guys, there's so much potential here. I'm like, I want access to that printing press. That's a $25 million Comexi printing press. It's got Siemens motion control on it, DH445 with XML-DA servers. There's a database on there that's been storing every work order that you've ever produced over the last 5 years. You don't even know it. I know it. You don't know it. What I want is 12 weeks. I want you to give me access to that machine. I'll pay for a proof of concept. I'll present it to you in 12 weeks, and if you like it, you buy it. If you don't, we'll rip it out. And I installed a server. We landed in our MES system, and I did a presentation with the ownership group, and I showed them 3 revealing data points that came from MES. Okay, so I showed them that they had never. I showed them that they had never set up a printing press the same twice for a specific product that they had run. They had a customer they were printing for. They had run their packaging 80 something times over the last 4 years for this customer, and not one time did they ever set up the machine the same twice. The tunnel temperatures were always different. The web tension was always different. The line speed was always different. They had never set it up twice the same. Okay, that was number one. Number two, they had 5 press operators that ran on that machine, and I was able to show them the operators who are most efficient, from most efficient to least efficient, and I was able to do an analysis on their personalities based on the data we collected. And number 3, I showed them their actual downtime and waste compared to what was being manually reported by the operators. And once they saw that, and I said, do you want this? They said, let's do the whole facility. So that's how you do it. That's how you do it.
Awesome. We still have pretty good retention. We're going the full 90 minutes here. We got a couple questions that just came in. And if we missed your question, like Doug, just bring it up at the chat again. Also, Vaughn, thank you for dropping that one in the back end. All right, so here's the question. Ya said, how can we win the argument when debating over SAP versus MES tool? We kind of touched on this earlier, but I just said, hey, schedule a quick discovery call, a digital strategy call with me. I could jump on a call for 15 or 20 minutes.
SAP is not connected to your assets. SAP,
that's the answer.
Yeah, SAP is not real time. It's transactional. That's why they have license tags. That's why they have message queues. That's why they have intervals. SAP is a business tool. It is not a manufacturing tool. I don't care here's how you win the battle. You put me in the room with the person who advocates for SAP, and
Yeah,
I will make
I was
sure
gonna say schedule a call with Walker.
And they will never. I've had this conversation. I've been in front of executives hundreds and hundreds and hundreds of times on this specific SAP conversation. SAP has never won. You want to know two companies who are fucking terrified of me? Terrified. Okay? Accenture and SAP. Because every single time a client has hired me to come in and be their voice to the SAP salesperson or to the Accenture salesperson who's selling digital twin, Accenture and SAP have lost every single time. The reality is this: if you have someone in your organization who is saying the centerpiece of our business should be SAP, they should be fucking fired. You go right to the CEO and you go, that person doesn't belong here. They're going to drive you off of a cliff. SAP is a node in the ecosystem. It is not the hub of your ecosystem. Your business doesn't take place in ERP. And let me ask you this question, gang. Who is the most digitally transformed business organization in the world? Who is the most digitally fluent manufacturer on the planet? It's not even open for debate. Who is the most digitally advanced?
Tesla?
Of course, it's Tesla. Tesla has a fully digital supply chain. Tesla's cycle time is 30-something seconds. Every 30-something seconds, they produce a car. Their next closest competitor takes twice as long. And yet, they've been doing it for 100 years.
90% OEE, too.
Guess who does? Yeah, they do it with 90% OEE. They stand up gigafactories in 18 months. Guess who doesn't use SAP? Guess who built their digital infrastructure? You want to see something comical? Ask Elon Musk about SAP. SAP is a punchline, and it's not even a good one. I hate to break the news to you. And I'm talking about SAP as ERP. SAP ERP. Go ahead.
All right,
Zach.
all right, you're going into the SAP rabbit hole. All right, I'm going to pull you back out. Doug asked a quick question. At a line level with many assets, any asset can contribute to bad availability. How do you use downtime codes from multiple assets?
Okay, line level, he's talking about cells. So at a line level with many assets. All right, here's the deal. So when in the example that I showed you earlier, the production line that did the high pressure fuel pumps, and it's got 16 assets, 16 cells. Okay. We were calculating OEE at each of the individual cells. But here was the question that we asked. We were also calculating at the production line. We asked the question, when is this production line down? You, Mr. Operator, when do you consider this line down? And the answer is when 8 seconds happens and a fuel pump doesn't come off the line. So if we have a downtime event and 8 seconds have transpired and a fuel pump doesn't come off the line, then we are down. So what did we do? We have a state register for each individual cell. Okay. We are tracking the individual cell events at every single cell. But then we are also, our downtime event happens when 8 seconds has transpired. If 8 seconds has transpired since the last pump came off the line, do we have a downtime event in any of the cells? If so, yeah. If yes, which one was first? That's our reason.
This one came from Vaughn from the chat. Does Tulip now offer scripting in the box like Ignition? Scripting in Ignition is one of the points you listed as keeping it as the gold standard of IIoT.
Mm-hmm. So the answer is yes, but okay. It's not the problem with that question is the like Ignition. No. So not like Ignition. No. Is there, can you script in Tulip? Yes, absolutely. But not to the level, you're not doing data operations. You can do data ops inside of Ignition with pure scripting. You can't do that in Tulip.
We got a lot
And
of
by the way,
people asking about SAP.
yeah, well, let's answer the SAP question.
Okay, well, this one first. Where would other KPIs like OTTP, labor efficiency, et cetera, exist? We rolled out
So
OEE, but are struggling culturally to tie in metrics that are already used and still important.
Very, very good question. So there are three metrics we didn't show you here that we could show you easily. We didn't add them as KPIs, but we should have. Okay. One is TEEP. Okay. So TEEP is the difference between TEEP and OEE is that OEE takes into account your schedule. Okay. TEEP doesn't take into account your schedule. It calculates total capacity. So when you're looking at the TEEP number is always lower than the OEE number. Okay. And when you look at the TEEP number, it's calculated the same way, availability, quality, performance. The difference is that the standard is the total actual capacity you could run in a year if you ran 24 hours a day, 7 days a week, minus minimum maintenance. Okay. So TEEP is a KPI we didn't put in here. Where does TEEP live? TEEP lives in the ERP system. It uses OEE data to calculate TEEP at the ERP layer. Okay. Mean time to repair, mean time between failure. Those are both calculated in MES. And those are two very critical numbers that fall underneath the availability scope. Okay. And then when you look at overall efficiency, especially labor efficiency, that is an ERP function that is using MES events to do the calculations. So that lives in ERP.
Okay. Ali said almost the same question, except that my company has SAP EWM as the WMS, Aviva Pi and LIMS, but no MES. Still stuck to convince executives that the need for MES. In his case, they confused because the company built some downtime and OEE capabilities in Aviva Pi, which is showing real-time data.
Yeah, but at the end of the day, it's not giving you the analytics. So what you built with
you're not doing OEE in your historian. You're doing it in the database.
Correct. And the reason why is because you don't know how you want to pivot it until you need to pivot it in a certain way. The capturing of the events is what matters.
And that's why we said you need to start today. And that's why we showed. That's why I built the demo.
State history.
I want to get these guys started, you guys and gals started today. All right.
So let me give you guys an example of a huge implementation of manufacturing execution we did for one of the largest companies in the world. They were an SAP house. What was the relationship between SAP and their ignition-based MES system? Okay. This was in the connectivity space. All right. SAP was the place where all the products lived, the bill of materials lived, and where the schedule lived. Okay. SAP would dispatch the schedule to the individual plants through a message queue. The MES system would consume the schedule, and we would convert that schedule into manufacturing orders in the MES system inside of Ignition. Every time there was an event related to a schedule ID from SAP, okay, every time there was an event, we would send a confirmation back to SAP from the MES system through the message queue. All of the events were captured inside of the MES layer, inside of Ignition and the various databases. The only thing that was being sent back to SAP were the confirmations of the transactions that SAP needed to consume. For example, this raw material was consumed. A confirmation was sent with a license tag. This work order has been started. However, you know what didn't get sent back? All the individual downtime events. There was a confirmation that went back to SAP that said this work order is done. The total runtime was this. The total downtime was that. However, there may have been 100 events before that confirmation that SAP never saw. Because SAP is not designed to capture real-time events. It is a transactional software, and it maps transactions to master data models. Any others?
Will
Yeah, he
will
said,
you be
hold on,
building a bat? Will you?
hold on a second. Arash, he says, you talk about manufacturing do the same thing. I see a big difference between high volume versus high mix type of production as a contract manufacturer in the sheet metal business with lots of customers and design complexities with having the goal of full-scale manufacturing from raw to assembled complex, how to come up with an MES system. By the way, the high mix, high volume that I just showed you, that the customer I gave you here, guess how many product codes they have?
Probably 1,000.
100,000. They generate 200 a day. 200 product codes a day. That connectivity company I was telling you, they were generating 1,000 products a day because they would make like USB ports and stuff, right? They would make connectors, and they would and some laptop manufacturer would go, we need a new connector, and they would work with the customer to build a new product. The fact of the matter is that, and it's hard to answer his question here concisely, but what you have to understand is that the engines used to calculate the KPIs that are used in manufacturing execution, they think of them as a series of function blocks that all wire together, okay, to serve the functions of MES. But the very first block in the workflow has 4 or 5 connectors that connect to the real world. 4 or 5 ingress points. And whether you're doing low mix, low volume, high mix, high volume, high mix, low volume, no matter what type of manufacturing you're doing, those ingress points are all the same. Okay? They're all the same. Are there here's a challenge in manufacturing execution. Batch. Here's a really good one. Think about Coca-Cola, for example, or Pepsi, or you enter in anybody who makes soft drinks. Their process is a mix of batch and discrete. They will mix a volume of soda. Okay? And then that volume, that batch, is going to go out into bottles. And those bottles are going to go into 6-packs. And those 6-packs, if they're going to Costco, are going to go into a box where I have 4 6-packs put together in one box. And then those boxes are going to go onto pallets. So I start with batch and I work my way to discrete. It is really hard to do MES unless you're able to track right down to the bottle itself which batch is inside this bottle. And the only way that they do it is they literally print the lot number on the bottle right before the bottle gets filled. Without that one event where they print that lot number and you can read it at the very end, you'd never be able to tie the events back to the batch. That's where your real challenges are. Oh, Daniel Halal, he wants to get me in trouble. Are there any major limitations in Sepasoft that would make you prefer building a fully custom MES? There are definitely places where I would use Sepasoft's modules. I just don't anymore. Is it where I would personally go? No, it is not. But that doesn't mean that there aren't people out there who use Sepasoft's modules and absolutely maximize them. Are there limitations? Sure, but I wouldn't say that the limitations you see with Sepasoft's modules are any more or less significant than the limitations you're going to see with any module. So, but if somebody comes to me and says, hey, Walker, here's my problem, should I use Sepasoft's modules? I'm going to say, well, it depends on who your architect is. That's really what my answer is going to be. Because the decision to use Sepasoft's modules are going to send you down this road. And if you want to, you're not just going to unplug Sepasoft. You're not going to just, you'll have to rebuild your MES from scratch. You're not just going to unplug it, you know. And the same is true for any MES module.
All right, so we had the Flow question. Where does Flow fit into this?
Flow software?
Yes.
So Flow as an analytics platform bolts onto the UNS. So when he was showing you what I was showing you, the unified namespace for that manufacturer and what he was showing you, Flow, their analytics platform, bolts onto that UNS. and then it pulls that data out. And let's say you've got a Canary Labs historian that's historizing the UNS. Flow is connected to the UNS and the historian, and so it's able to go back and retrieve all those historical records, and then you can do the analytics in Flow.
They call that the Unified Analytics.
Yeah, Unified Analytics Framework, UAF.
UAF. How does APS relate to MES?
I'll shoot a separate video there. That'll take me 20 minutes.
All right. Are there any other questions? Drone asked a side question. Have you ever found developers that scoff or act flippantly about the UNS concept? Yes, but they eventually come around.
Yeah, there's never, let me say this. I've never met anyone who didn't come around. I mean, there was even, there's a guy, he's a member of our community now. I think he follows me on Instagram too. He joined one of the large automation companies. This was maybe 8-10 years ago. And probably 8 years ago, we were talking about UNS. And he commented on a bunch of YouTube videos, and he was very contrarian. He was hardcore questioning unified namespace and things I was saying. And he's a true believer now. Everybody
don't
who
like
takes
your people take issue with your delivery, and then that turns them, they're not receptive to the message, you know?
Correct. I mean, but I'll be the first one to tell you, like, I don't want to be on camera. I don't believe that I'm the guy who should be on camera because of what my personality is like. If I'm right, I'm going to push hard. If I think I'm right, I'm going to push really hard.
All right, we're going to, we're pushing 80 minutes. We're going to keep staying on this call until we answer all the questions, even if we have to stay 2 hours. If you have to drop, we understand. Yeah. But Jonathan, which ERP, what's a solid ERP you would use to weave into an existing bespoke built MES? Would it Odoo?
Okay, so this will probably surprise people. In order. Okay, with the caveat that the ERP you select should be a function of the type of business you're in, right? I mean, like if I'm wholly doing batch, then a batch master is going to be my choice, right? But let's say that we're not going process specific. In order, especially if you're a smaller manufacturer, I'm starting with Odoo for sure. Okay. Odoo is going to be my ERP. It's the most flexible, the most open, most extensible. Then the new Epicor, the way Epicor has changed changed the way they're going to market. Epicor now is approaching the going to market as a node as opposed to the hub. I believe SAP is a very good ERP system for enterprises. If SAP would stop trying to sell to the customer that they can do everything. If SAP just focused on master data model functioning, financial reporting, okay, bill of material management, if they focused on building the master data model of the business and then managing the individual debits and credits transactions, SAP is a great enterprise ERP system. But if you want to know the truth, 2 decades from now, ERP won't even exist. There won't be a suite of tools called ERP. What you'll have are individual manufacturers will have their own digital infrastructures made up of namespaces that serve functions that used to be ERP. Like you'll have a namespace called BOM. Okay. You got to remember where ERP came from. ERP is an IT tool. Manufacturing is an OT business.
Another question from Doug. What about a manual safety stop? How would an operator enter a reason code for what type of stop it was, i.e. jam?
So that's a classification. That's a separate table that points to the event. So in fact, in that client I was showing you, they actually, if you looked at there was the categorization of scrap. There's also a button where you categorize the event itself. So they would select on the event and then they would click categorize. It would open up a view that is then going to join. They'll select the category. They'll put in the operator. They'll enter it. And what it's going to do is create create a record in a separate table that points to that event in the state history.
All right. There is another question. What should I ask the supplier of a new factory about the OE calculation and the system they provide to determine if we can trust it?
Well, okay, I don't have enough information to answer that question, so I can just give you an example. I had a manufacturer who was calculating OE by hand on paper, and they were calculating at 82%. I could see that the way that they were doing the calculation was flawed. Okay. For example, when they were the availability, that number that they were using was not the actual availability of the production line. So, for example, if the production line was ever down, let's say they had a catastrophic failure and it was down for 3 hours, what they would do is they would schedule a safety meeting during that 3 hours. And so in their spreadsheet, they would say it was a safety meeting, which was planned downtime. So it would never get dinged on the availability because it wasn't scheduled to run during planned downtime, right? What we had to do was we had to capture the raw events, do the calculations ourselves, and then show them the real OEE number compared to what they were calculating. And in fact, in this case, that director of operations was fired for that customer. I've told this story a bunch of times where I went in front of, it was a Japanese company. We calculated the OEE. He was calculating at 82. We calculated it in the low 30s, upper 20s, I think. He lost his mind. That's fucking bullshit. There's no way that's the number. And I was like, and they called me in and they put us in front of a whiteboard and I had to show how I was calculating. And I showed the rising edge and falling edge of each event. I was just holding the tablet in front of me. And then he showed how he was calculating his and they asked him to leave. His boss went with him and he never came back. That was the same company where the CTO was fired also.
Any quick opinion on building MES in Ignition with a GE digital backend, historian, and white labeled Kepware?
I like it.
Yeah, let's do it.
I like it. Yeah.
Can we make a separate webinar for the example related to Pepsi, the sugar water manufacturer,
yeah,
and the general food and beverage industry, like a food and beverage webinar?
Yeah, we can do that. In fact, we have a bakery example we could use too.
Are you using PackML or WinHand-Stefan standards in your applications?
PackML, yes. Where it applies.
All right, I think that's all of the questions. I want to. A lot of you guys are at different levels of digital fluency, whether you're just getting started. We have a lot of advanced developers on the call. You guys could probably take what you learned in this free training and apply it and get to where you want to go. If you want to go through the MES Bootcamp in a group and accelerate that learning journey down into 8 weeks, we are doing you can pick up the you can join the 8-week bootcamp with the coupon code MBA500. That'll get you $500 off the investment.
Well,
to join
isn't
the
that
8-week
fancy?
Bootcamp.
Isn't that fancy?
that it's not expiring this Friday, but it's expiring next Friday. So you got till next week.
Zach knows I hate this. I hate the commercial stuff. I fucking hate it.
I had to drop it in there.
But I made it this
far.
I like the MBA 500 stuff. That's kind of cool. Let me say, what do you walk away with from the bootcamp though? You should walk away with a VM that's got an MES system running on it that has ingress points so that you can basically plug an asset. You could literally connect to the gateway to Kepware that's got state, infeed, outfeed, and waste. And then you can map that into the ingress point on a production line. You could generate work orders. You can schedule the work order. You can start the work order. You can calculate the OEE. You'll show it on a dashboard, all that. But you'll also end up with like a library of scripts and all the tools to start doing basic MES at an absolute minimum. State history is what you really want to track, but it's also the MES system that you build is one you extend. And I've looked at some of the MES systems that people have extended from what we did in bootcamp, and it's pretty sick. Like I was really impressed with a couple of different implementations that a couple of the students did. They took what we did in boot camp and they took it to a whole other level. I mean, it was very, very impressive. But I will say this, no matter what you do with MES, it's very important. If there's any lesson I want you to take away from this, you will build MES. You will build. Now, will you build from scratch? Maybe, maybe not. But you are going to build. That I can guarantee you.
All right.
So you better learn.
Do our services, do we reach to a Canadian manufacturer?
Yeah. Mm-hmm.
Awesome.
Absolutely. And we have partners too.
All right, guys. Thank you all for joining. Mario said, will you show where the scripts execute? Yes, we're going to be diving into all of the inner workings of the MES platform.
You'll see the raw script library. You'll see how to call a gateway scope script. There's actually an OEE package we create. So from scratch, it's going to be MES. I think it's called MES Lite.oee is the package, and then all the functions in that package. Like, I'm even going to show you how to change the calculation in the video. I show you how to change your OEE calculation. So I even show you where you would edit the code. If, let's say, you didn't want to calculate OEE, you want to calculate, AP, which is just availability and performance. I show you where you would change it so that you're not incorporating the quality calculation.
And if you sign up for the 8-week bootcamp, we're going to be on January 7th. We're going to be reviewing Module 1. So your homework is to sign up for the bootcamp and watch Module 1 and attend the call. You'll get a link to join the call to review Module 1.
Are we sending out a feedback for this?
Yes. And also, we're going to have to do a quick edit, and then we'll make sure we send out the recording to everyone. Everyone who goes to the bootcamp will watch this free recording first, then watch modules.
Yeah, we're gonna pull the Sepasoft answer out. So before we make it public.
So if you guys joined live, you got the,
if you guys watch it live, you got the real answer, but I just can't take, that's a fight I don't want to have anymore. All right.
Thank you.
Appreciate
all for joining.
you guys.
We'll see you guys on the next one.
Thank you. Bye.